All right, on this lovely day, we're going to be spending some time recognizing something called the role of z-scores, something you've probably never heard of before. So we'll unpack what that means, this mysterious z-score, and we're going to use them in standardizing data. Okay, so by way of warm-up, you're going to calculate the mean and the standard deviation of the following median hourly wages circa 2007. So food production made $8.24 per hour, and management made $40.60 per hour. So the mean, of course, all you have to do is plug all these into L1 and then do the stats on that one. So if we write this as a dollar amount, the mean is $22.90 per hour, which sounds pretty good to me. And then the standard deviation S, notice that we're not using sigma because we're not talking about a sample group of people. This is salaries. All right, and so now we have $10.7. What we're going to walk through now is this idea of a z-score, and the two most important pieces of the z-score are these two numbers. So we do have to always calculate these when finding what's called the z-score. And let's walk through some ideas of the z-score. It's also called the standard score. Because, and actually there's probably 3 or 4 other names for it, but we're just going to stick with z-score for now. It's a number whose unit is standard deviations. Standard deviation. In other words, this score is 2 standard deviations from the mean. It is 1.2 standard deviations from the mean. It's negative 0.2 standard deviations from the mean. So the unit here. Up here, the unit for the mean was dollars because everything else up here is dollars, so the mean is dollars. The standard deviation is dollars. But this tells you how many standard deviations away from the average you're going to be. And there are 2 ways that we're going to use this number. Number 1, it's going to compare one element with a group. So how is your score on the midterm relative to everybody else's in the group? Okay. It also can compare elements from one group to another. So, for example, we're going to look at a scoring in a basketball, the average points per game in a basketball. And what we can do is compare how do the varsity players compare to the JV players. Because clearly, a varsity player might score more than a JV player, just raw numbers. However, if we talk just within this group and compare within this group, we can actually see who's doing better overall. So we can compare from one group to another by ultimately by comparing one element to the group itself instead of to all people everywhere. So let's talk about how to calculate this thing, and then we'll practice it and get you going. So here's the definition of z-score mathematically. Suppose a data set has a mean, x bar, and a standard deviation of s. The z-score for the member x of this data set is the deviation over the standard deviation. What you do is just subtract it, right? So this is the element. For example, I'm 5 foot, so a person is 5 foot 11 inches. And the average we're subtracting is 5 foot 8 inches, and over the standard deviation of whatever. So this score tells you how many standard deviations, how far away from the average one element is. How far away from the average relative to standard deviation. So you're going to need to use your TI for this. And I've already entered, so hopefully you've already entered the L1 information in. Now what you're going to do is translate that data by subtracting the mean from all of L1. Then you're going to take L2. So this one's L1, this one's L2, and this one's L3. So you're going to translate the data, and here you're going to scale the data. You're going to divide everything by the standard deviation, which we have those 2 scores above. So slide everything over, subtracting 22.9 for those, and then divide that L2 by 10.7 there. So after we enter the data into our calculator and have it auto-calculate things, we're able to see how things compare to the group. Now, here's the problem. We know the wages, they instantly make sense to us. L2 doesn't really make too much sense to us. Why did we shift it over? But this number down here now tells me how close to normal everything is, or normal being the average or the mean. So here's management. It is 1.7 standard deviations above the group. And it's important that it's above the group because it means management has a higher wage, significantly higher wage. This doesn't mean nearly double the average. It just means that it's way outside of the normal. So let's see how it falls. This right here, there is a rule called the 68, 95, and 99.7 rule. You are not going to be quizzed on like knowing exactly that part right there, but the idea behind it is this. In a normal bell curve of information, if this right here is my average, and this notation down here is using population information, so they would probably, instead of saying average like that, they would use the Greek letter mu, again, because that's a population instead of a sample. All right, so if you are within one standard deviation above or below, 68% of the population, or excuse me, 60% of the information is going to fall in there. So this here is very, very normal right here. So between 1 and 2 is outside. Notice that almost all the data falls here. 95%, that's all this right here, the kind of like the area underneath. 95% of it falls within this region here. And then this little sliver and this little sliver represents just a little bit more, less than 5%. And then way over here, if you're above 3 standard deviations, that's like the top 0.3% of the situation. Now, by the way, in the history of the world, in terms of being rich, you are over here. You currently, in your current state of being, you are top 1% in the world. So this is you right here, in terms of wealth. Right now, I'm not even talking history, just right now. So this is not you. Now, that's talking world. Now, if we talk here in America, many of you will probably fall, I don't even know where exactly, but it would probably fall more in the normal. Or if you look at Boylston only, then you'll live here. But in terms of the world right now, and in terms of the history of the world, you're out here. You're one of the richest people in the history of the world to ever live. End of subject. So this means that they're falling right here, which, as we can see, it's not perfectly proportional, but it's probably in from the 68% to the 95% range. But clearly it's closer to the middle of that, probably closer to, 78-ish. But that's just a guess. I'm not going. So because that person's scores out here, they're top 25% of wage earners. Top 25% of wage earners is over there. So just to give some perspective on Z-scores, if your Z-score is above 0, that means you're above the average or above the mean. And of course, the inverse is true. You're below the mean here. If Z equals 0, you are the mean, like so. And generally, know this to be true as well. 1 standard deviation is 68%. 2 standard deviations is 95%. And 3 standard deviations is 99.7%. So when you see a number like this, negative 0.2. Oh, that means it's slightly under the average, but certainly within the norm. 0.3. Oh, slightly above the average. So 0.3 standard deviations above the mean. So it's slightly above and also within the norm. This guy's within the norm too. All of these are within the norm right here. But this one here is quite a bit lower, and this one here is quite a bit lower. higher. There we go. All right, so her z-score is 2.13 standard deviations above the average, or above the mean. So if we were to consider the bell curve, she is outside of 2, closer to 3. So she is way up there, above 95%. Above 95%. So relative to her compatriots, she scored significantly better. All right, now let's look at Ned here. So please take a moment to calculate his information on a separate quiz. All right, so look at this one here. Ned scored slightly lower, and we see that we have a negative situation for him. So he scored negative 0.7 standard deviations. And of course, we can interpret this as to being below the mean. And since he's within 1 standard deviation, he's within a range of normal for the class. Normal for the class. We're not saying normal according to scoring 100% on everything. We're just saying normal to the relative to the class. So what's interesting now is that we can take information from one group and another group, and we can compare them across the situation as well. So even if, for example, even if Ned scored higher, which we don't know the total score on the pop quiz, but even if Ned scored higher as a raw score, he might have scored lower relative to his compatriots. So what you would say is, oh, Nancy did better if her z-score is higher. So who did better relative to their classes? Well, Nancy did because she has a higher z-score. In this last problem, please enter data into L1 and L2. What we need to do here is the following data sets show the average number of points scored per game. So one player scored average 4.7 points per game during a regular season. So the top 2 are all about varsity, and the bottom 2 are all about JV. So if you enter all of this probably into your, well, it doesn't matter how you organize it, but I would probably go L1 here and L3 here. Although maybe L2, and then just as long as you pay attention to what standard deviation applies to what. So then this one would be L3 and this one would be L4. So make sure that when you are converting this, you do both the translation and the scale all at once on the L3. So let me walk through what we did here. When we're converting, we can use the handy-dandy calculator to do things. So what we need to do is for L3, since L1 is connected to L3, what we're going to do is we take L1, and then we're going to subtract the mean of L1, and then we're going to divide by the standard deviation of L1. Now, all of these are in our calculator. So mean and standard deviation are under the list menu and under math. Okay, so we can go into L3 at the top, plug all that in and get the data here. So let's analyze the data and see how things work. So remember how things are going. If a z-score is very close to 0, that means this is very close to the average, okay? And it's underneath 1 standard deviation. It's within 1 standard deviation. So we know that this is very much in the normal. So this is very normal, very close, and it's positive, so it's slightly above the average. Here is negative, and it's actually on the outskirts, getting close to outside the norm. And the question here, which of the high scorers did better relative to the rest of the team? So the high scorer on varsity was 18. So this athlete scored 18, but the z-score, 18.5, but the z-score was 3.12. And as we saw earlier, a 18.5 translates to a z-score of 3.12, which means in the top 99%, way up there, even above that. Okay, so let's look at the other top scorer. The other top scorer on junior varsity was a 10.4 right there, and z-score corresponds here to a 2.47. So that here is a good score, but again, that's only in the top 90, close to 95-ish percentile. So, so clearly the varsity player here had a better z-score, so better relative to the rest of the team. Okay, now let's compare things with the second best. So in the varsity level, the second best here was a 9.2, and the 9.2 corresponds to a 1.1. Now, the 1.11, that's important, because the JV, the second best, was a 6.9 here, and that corresponds to a 1.19. So the JV number 2 had a z-score of 1.19. So since that was greater than the 1.11, that means this person here, relative to his or her team, had a better season. So that's how we can interpret z-score from one data group to another.